All right, today I've got a case that I think is maybe a little bit interesting, so I thought I would, hey, let's make a stream and see if we can figure out what's up with this iPhone 6 Plus. So this is coming here for a no power solution. And at first it's not clear to me if that's actually a no power phone or not, or if it's maybe just a no image problem. So let's see what you think, and first start with a examination of the board. So I've got the board out, and we can take a tour looking for water or cracked coil, signs of drop, something like that. And I don't really see anything on this board. It looks pretty normal. It seems like I was the first person to take this back sticker shield off. No water here by the sim. You can see a couple of places where I've been probing around a little bit. And you can see that I changed TriStar, which is kind of like an oil change for the iPhone 6 Plus, just to rule that out because it was not connecting to iTunes. But it seems like it might be booting. So that wasn't it. Over here on the top side of the board, I don't see any water. I didn't take off this shield. If you are this customer, this is your board. Get excited. We're gonna see what we can do. Nothing remarkable here. I don't see any evidence on a 6 Plus. I'm always looking to see, hey, has somebody been messing around in the Mason chip area, and it looks native. So I don't think that this is some sort of a prior repair attempt for touch. And let's look for long screw damage. So let's look in those screw holes, and we want to kind of flip the board at an angle. We don't care about trash in the trash can. All we care about is the bottom of the trash can intact? And for these screw holes, it looks like the bottom of the trash can is intact, so no long screw damage, no sign of water damage, and no real explanation. This board should work. This should work just great. So let's do what we're gonna do with any phone that comes in as no power, which is to ask, is this actually no power or not? So let's take a look at it on DC power supply. So we are going to use DC power supply, which my favorite one that's really easy to read is here. I just got a new one today that I'm working on figuring out whether or not we can graph some DC power supply signatures for these terrible, awful iPhone 7s with their, finicky boot looping problems, to see if we can kind of pinpoint baseband problems from audio IC problems by working up boot signatures, so kind of pattern recognition. So let's stick a dock and a screen on here, and then we're going to connect to DC power supply. And maybe this will be a short little video because there's nothing wrong with it. Maybe. Let's find out. Let's find out. All right, we've got some folks joining us on chat. Hello, everybody. Everybody on chat. All right, let's connect this up to our battery connector squid. We're gonna plug that in. And we're gonna find the 6 Plus magic connector and connect to DC power. So you want to be looking right here to see what does the DC power supply signature look like, and I hope that you can see that on YouTube. I think it looks okay. All right, so far so good. This is 0 current consumption with a full battery voltage being pushed into the device. So right now we have our battery power rail, our main power rail is all filled up with blood, but nothing's happening because the phone hasn't been prompted to boot. That's normal. You don't want your phone to consume current when it's just sitting there in the off state. So now we're going to prompt it to boot. I'm going to prompt it to boot with a USB cable, and I'm just going to prompt, and then I'm going to pull it out so that it's drawing current just from the battery connector, not through USB. All right, so we're going to see what this looks like, and we can see these numbers here. That looks normal. That looks like this phone is booting. Now let's watch it. So this sort of normal behavior is a lot of flickering around, and you can see how that would really be informative to kind of graph it out. Getting up over a little bit over 1 is normal during the boot up sequence, and then it usually comes back down All right, that seems normal. So let's see if iTunes can actually detect it, in which case it's not a no power problem. All right, iTunes, do you see this phone? Hello, iTunes. So I've connected it to the computer and I'm listening for that, you know, hey iTunes says, I see a phone here, and I'm not hearing that, which is a little bit odd. Considering I think that looks like a normal boot sequence. So what's up with that? All right, so we could question parts, but I've just recently used this same dock and this same setup, so I'm not really worried about this being a bad dock, bad connector. We looked at the board. That seems normal. Why are you not detecting iTunes? Let's try it again. Hello, iTunes? Nothing. All right, so given that we know, hey, this phone is not able to detect iTunes, even though it has a really normal looking DC power supply consumption, looks like it's normal booting, let's really study it and see if we can figure out, you know, hey, in what way are you abnormal? So it looks fairly normal. It's hanging around in the 30s and it spikes up to 1 and then it seems to come back to this 0.3. Spiking up to 1, coming back to 0.3. That can be a normal behavior, but it keeps sort of going up to this 1, like that, above 1 amp, and then coming back down. So the normal sequence is for it to kind of hover around and then hit 1, above 1 for a little bit, and then come back down and stay down. And especially in a phone that's not producing a backlight. And you can see here that there is no image and no backlight. So if I split this screen, I don't see an image and I don't see backlight. And my camera's gonna go to sleep. Fantastic. We'll wake him back up. All right, so that's an odd problem. That's why I wanted to do this one with you guys, because this is not a typical presentation. And you can see why my first thought was, let's change TriStar. Maybe this phone actually is booting and we just have an image problem. And the reason why iTunes can't detect it is because of a TriStar USB connection recognition problem. So that's why I changed TriStar. And it's in the same state as before. So what do you guys think we should do? Let's see. I have that same power supply phone I was working on today. All right. For sure, it should work because of the master's touch. Let's try, just for the fun of it, let's try out this new DC power supply, which is, I got this one because it is, at least in theory, supposed to be able to show you a graph. And I think that would be really cool. I'd like to save these graphs, and I'd like to ultimately post them on iPad Rehab Forum so that we can all kind of start to use DC power supply sequences as pattern recognition tools to try to figure out what's up with some of these phones. All right, so let's move over the old power squid and plug it into the new guy here. Now, I'm not as familiar with this one. He doesn't feel like home like the other one does. I don't like his teeny tiny display. I don't like only having, you know, like these two tiny little digits up here. But I do really want a graph. So this particular version of power supply I'm trying out, and I also have another one on the way. I want to see which one is going to be the best solution to kind of get the iPad Rehab recommendation, and I'm not sure about that yet. All right, so let's do the same thing over here, and let's see what the graph looks like. Sounds fun. I don't know if we'll be able to see it. I also don't know how to make the old hand cam zoom. It's a GoPro. Do GoPro zoom? Anybody know? Anybody a GoPro guru? All right, so we're gonna do the same thing, prompt to boot. Actually, I think I have to turn this one on 4 volts. Yes. Okay, seems like that should be a go. All right, start booting. And now I'm going to pull this out, and in theory right here we can see, and this, I don't like the scale, and I'm not sure that I'll be able to adjust that scale, but you can see this tiny little graph. It's going up to 0.3, 0.5, 0.3, and it's starting to trace this little boot signature. Let's see, can you guys see that any better if I make it even closer? Can you see it at all? All right, you can see now it's at 1 amp. 1 amp. And now I'm booting it with my finger on the board. So my fingers are touching the board, and I feel an unusual amount of heat. And that's a clue. This board feels hot, not just the warmth of a normal booting board, but it feels like it's gonna have a hot spot somewhere. And that's a big clue. Heat equals short, and short circuit is a problem that we love to have. All right, we can see the little graph. See the graph? I think that's pretty cool, the idea of being able to save power, you know, these sort of power signatures and use them to identify faults in the future. Look at that. It looks like some kind of funky EKG. And it's hanging out at this 0.3, and then it goes up to 1, and then it comes back down to 0.3. See how it's tracing that pattern? Look at that. That is very abnormal. See it? I wish I could get that a little bit closer. I feel like picking up the power supply and shoving it in the face of this camera. Look at that. That's like a very abnormal heartbeat looking thing. iPhones are not supposed to have heartbeats, especially not when they're dead. All right, so from there, now we have another clue. We have a clue that there is heat on this board. So let's see if we can use that to our advantage to try to find out, is there a short circuit? Now, I've already looked at this board a little bit because it's more fun to do a stream when you have a little bit of an idea where you're gonna go. So my next step would be to probe around and see if there are any kind of like known lines that go bad. So I checked for shorts on 3V0 NAND. I checked for some of the power management chip outputs, and I didn't find any short circuits. In fact, I checked around this board for a while and I didn't find any short circuits, but there's heat. So could we have a partial short somewhere? And if we do, how are we going to find it? Because that's a pretty tough problem to find. All right, so when we don't see any physical damage on the board, so I don't see anything up, and when we can't just probe around with a multimeter and find a shorted line, which would then give us a lead to kind of figure out who's the bad guy, then we're left with our last tool, which is, can we use heat? Can we find heat to at least give us a clue on which line is shorted? And then we can kind of use experience, hypothesis, how did it come to be like this, history, to try to hone in on what the actual problem is. All right, so let's see. Possible short on backlight circuitry. All right, backlight circuitry, that's not a bad idea. We can investigate that. So, yes, toss out your ideas. Let's see what you guys think. What would you do in this situation? Measuring backlight would be a great idea of sort of the typical lines that generally fail. So let's give it a shot, see what the deal is. Let's go over to Microscope then, and in diode mode, let's take a reading on the yield backlight line. All right, so we'll put a red probe on any ground, and then we're gonna find the backlight lines. What is it? Isn't it pin 3, I think? One or the other of these, I think. Yep, so those are all coming up as normal. So I don't see a short in that area. Yeah, I should probably look up exactly what, maybe it's this pin 1. Let's find out. I don't remember. We don't see a lot of 6+ for backlight. All right, 0.622. And that one I'm pretty sure is supposed to be ground. 0.453, which I might be confusing with 6S. 0.623, 0.512, 0.513. All right, and we should probably confirm that that middle one, that one is supposed to be ground there. Let me just look on my handy dandy donor board. 6+. Are you supposed to be ground? It is. All right, so no backlight short. Now we need another idea. How about let's use heat? So we've got a couple of strategies to try to find heat on the board. I could feel heat just with my fingers on the board when I was kind of, you know, touching it. I always lay a hand on it while it's booting just to kind of get that clue. All right, let's see. Maybe touch IC short. All right, well, how would we test for touch IC short? There's the touch IC. It does not have a prior repair attempt. So give me an idea if you want to do something. I'm guessing 1V8 line. All right, well, let's look at the old 1V8 line. I would guess that a 1V8 line wouldn't have this really cyclical behavior. I'm good, 1 amp, nope. Okay, I'm all right, 1 amp, nope. That's a very, very odd and unusual power supply. Typically, a short will, you know, start out with a normal boot sequence up until a point, and then it will stay very steady because the shorted line is having current dumped into it the entire time. So we're looking for some kind of a line that is has some kind of regulation where it's on and there's a short dumping into ground and then it's turned off and then it's turned back on and it's turned off. So something like that would be a little bit more fitting with our DC power supply. But let's go ahead, and we're taking ideas from chat. And I got to vote for, hey, let's check on 1V8. All right, let's check on 1V8. So 1V8 we can check out here by NAND. And 0.307, that's a normal reading, so it's not 1V8. And we could do this all day, sort of a candidate, you know, candidate gene approach like we used to do in molecular biology research days. I already did that. I didn't find anything. So let's move on and see if we can use heat. How about we try the tool that I love to hate? Let's try the good old thermal cam, and let's see if either I'm wrong, thermal cams are fantastic and I should be using them every day, or if my opinion holds true, which is thermal cameras don't really have any place in board repair. So let's find out. So we've got our board down here, and let's see if we can hook this sucker up. So let's see, this is my good old FLIR 1. So let's see, I don't use him very much, so hopefully we can make him work. Let's see, FLIR 1, and we're gonna pick FLIR 1 close up. Ding. All right, connect the camera. So it's this little thing on the back. Connect camera and open the shutter. Will do, boss. All right, is this the $900 model? No, it is not. No, it is not. Although I did see after Lewis's video, which I think the problem with it, with the $900 camera, is just that it doesn't have zoom. You know, like not being able to zoom is really, really tough. But I think that for maybe for a MacBook board, it might have some utility. I'm not sure. Whenever you consider buying a tool like this power supply, is it going to pay for itself over time? And that would be my concern about a $900 thermal cam. Tuning complete. Okay, so now what I like to do with this thing is I like to put it in the mode, well, I like to keep it in the drawer and never use it. But if that's not an option, I'm going to put it in the sort of hotspot setting. All right, so I can ask it to show me a hotspot, like the hottest thing around, and show that in red. So let's see if we can pull this a little bit closer. So here's the board down here, and let's see what happens when we connect it to DC power supply. So I'm going to go back to my tried and true just because it's easier to see for you guys than the new graphing one. And I'm not sure I'm really in love with this new graphing one. I'm hoping the other one is going to be a little bit more impressive. All right, especially because ultimately I've got to get these graphs to show up on the PC, and that might be tough. All right, so we have a board that is hooked up to our DC power supply. Let's see if we can put it, let's see if we can prop it. Let's prop it up a little bit. Maybe something kind of inert like this thing will help you guys be able to see what the FLIR cam looks like. All right, so now here's our board, and I think you guys can see this. All right, so that is what our board looks like with the FLIR cam on right now. So right now you can kind of see that line view, and that's fairly clear. And as far as zoom, I can just hold it closer, and I can actually zoom pretty well just by getting closer to the board because I'm holding it in my hand. All right, hopefully I'm not going to make you guys throw up here. All right, so now let's prompt it to boot and see. Connect camera and open shutter. You asshole. I'm gonna be pissed if the camera ran out of batteries while I did my little rant. What's your user in Discord? Oh, I don't know. It's not even open right now. I mean, Discord's cool, but if I'm gonna do a Discord stream, then, which I think is a cool idea, then I would, you know, kind of like figure out how to have some folks all like ready to go in Discord. We'll get to that one day. All right, so far I have this thing telling me that there's a hotspot on the board. The board is not doing anything right now. It is not prompted to boot. And according to my calculations here, FLIR cam is telling me, hey, you know, you got a hotspot. See that? It's ah! All right, we better get this show on the road because it looks like the camera is running out of batteries. Probably because my my typical use is leaving it in the drawer for long periods of time. All right, connect camera and open shutter. I did. Connect camera, open shutter. Come on, we need to get like one good reading out of you. All right, here we go. I did connect camera and open shutter. You asshole. Connect camera, open shutter. Ugh. Have I mentioned that I hate this guy? Boo. All right, let's see if I can dig up a way to plug him in. Oh, great. And that camera's going to shit the bed as well. No, you don't. No, you don't, buddy. No, you don't. It's not quite quitting time yet. All right, let me look in my drawer of cords. Does everybody have a cord drawer? Is that like a thing? We just have a whole bunch of random cords. Some days I envy the neat desk people. Messy desk people have drawers filled with random cords. Neat desk people have cords like organized. That sounds like it would be pretty handy right now. I may not be able to even find a cord at all, which is gonna suck. How about in cord drawer number 2? What a pain in the ass. I wish I had just taken the stupid reading as soon as we started and had less bullshit. Oh yeah, look at that, cord drawer for the win. Boom. All right, so I'm gonna plug in the camera itself. One of the things I don't like about this is that the camera can't charge, I don't think it can anyway, from the phone being charged. You gotta like, it's its own thing. It's its own separate attachment. All right, let's wake this guy up and back in biz. All right, let's see if this thing is going to work now. Connect camera and open shutter. Pull and hold the handle to tune. God damn it. I kind of think that what we should do is let this guy maybe charge up for a second while we do our preferred method. That's not that, I mean, like, this is the thing that I hate about thermal cameras. You're always going to have this kind of nonsense. You know, you're probably not going to be using it every single day. So every time you want to use a thermal camera, it's going to be a whole lot of pull and hold the handle to tune. Tuning complete, release handle. Great. All right, so while this is behaving, let's prompt this sucker to boot and see if we can see a hotspot. So I'm going to plug it into USB, prompt. And I'm going to disconnect it from USB. And let's see, can you guys see, what does it say? It says, kind of getting hot somewhere up here. All right, so really all that is telling us is it's getting hot on one side of the board or the other. Now we can position that red spot and it'll read that temperature reading. 106 degrees, 108, 110. Now 120, 121. So something is getting really hot. That is significantly hot. That's hot enough that you would feel it. If you were to use, for example, the face detection method, you would definitely be able to feel where that is. Now we don't know what side of the board that's on, so we can just kind of, you know, feel it. You know, this to me with my thumb isn't that hot, but I definitely feel it on the back of the board. So let's flip it over, and I'm having to use my thumb. Let's do it. Let's use the face method. How hot? How hot are we? How hot is this? You know, that's hot. I got a hot spot. And my face says that it is somewhere around here. Let's see if the FLIR cam can tell me exactly where on this side of the board. All right, here we go. FLIR cam, where is it? It's like, yeah, you were right. So somewhere around there. It's pretty hot. So that's what we can do with thermal camera FLIR 1. It can give me a general idea. I mean, that's not terrible. I mean, it excludes much of the board. I know it's not down here, but it's kind of like, all right, it looks like it's somewhere in this area to the side of the PMIC. So there you go. That's what we can do with method 1, the FLIR camera. Let's see if that is the best method here. So we're going to put that to the side, disconnect from power. All righty. And we are going to go for Jessa's easy, tried and true. Free spray, super cold. Let's let this board, I don't want to put free spray on a board that is 120 degrees because I don't want to cause any kind of stress cracks. So what I'm going to do is let this kind of cool down until it just doesn't feel hot. I thought she said blurp cam. Capacitor by PMC. Hand warmer, perfect, yes. The red spot is just a reflection. I fixed one before, almost the same. When I push little on the power chip, PMIC phone boot normal. But you have heat, maybe any capacitor short. Yep, so we've got a short somewhere. We know we have a short, that's all we know. And I think it's important to kind of point out here is that not every problem is a short. In fact, I titled this video like, is there a short? If there's heat, this is hot enough to make you go, oh, that's hot. Hot, heat is a short. If it's warm, that's not necessarily a short. If it is behaving in a DC power supply, if it does not have any kind of high current consumption, and this one does, it goes 30, 30, 30, 100, 30, 30, 100, 30, 30, 100. That time above 1 amp, that's a short. It's a short that's transient. It comes and goes, but that is a short. If this phone was just low, super low on DC power supply, then it wouldn't be a short. So not every problem is a short. You could have a phone with a dead CPU. That's not a short. You could have a phone with a problem on any of these data lines so that it sounds like, you know, noise and nobody can understand what they're supposed to do. So an instructions problem. You could have a software problem. None of those are short circuits. So not every problem is a short. Heat, though, heat is a short. All right, so one idea is, all right, now that we know the general area, what happens if we just kind of hunt around for it then? If we say, hey, there is a short somewhere around here, could we find it by hunting around? What if we just go to good old continuity mode and put one, just park a probe here on ground. What up, Christine? Hello. We're doing a little short detection video. All right, so then can I just kind of like find, for example, a capacitor that has a path to ground on both sides, which would be inappropriate. Answer, no. So with the, you know, kind of modest amount of effort here, I'm not able to just hunt around it and find it. Although that's a great strategy. However, you never want to get trolled. You can get trolled really easily doing that when you do something like this. Ooh, look at that. I heard 2 beeps. A second ago, I sure did. You can get 2 beeps on some of these caps that are on low resistance lines like GPU and CPU power lines. So if you think you haven't found a shorted line and you look it up on the schematic and it says PP CPU, that ain't it. Because those lines have a natural low resistance to ground and they're never going to, you know, be the cause of the short. Almost never. 99.9% never. So that's not going to be it. All right. Board is cool. Let's go for this freeze spray. All right, so we will put some, let's get our dock ready. So let's just see, in terms of time, efficiency, cost, let's see what we can learn from just keeping a can of freeze spray next to us and see what we can do. All right. Just the power supply was moving. Watch that it doesn't fall. Yeah, it doesn't really fit on here. There you go, buddy. All right. So we are gonna connect this up. All right, so it's your choice. Microscope cam or hand cam. I'm gonna pick for you. I'm gonna pick microscope cam. So for this, I can see a little bit more looking down through the oculars than you can output to the screen. So we'll kind of say, well, let's look around in this area just so that we can get better information for you guys. But really, we would be able to kind of see this entire board. Now, from our face, we know, hey, let's look on this side of the board rather than the other side of the board first. Although the shorted line could be anywhere, and the guy that actually gets hot isn't necessarily the cause of the short, but we're gonna go with this for now. All right, so I've got it connected to DC power supply. Let's freeze this sucker down. Everybody always likes a good freeze spray. Good freeze spray day. Plus, this is what it really feels like to live in Rochester right now. All right, so it was somewhere around here. It was around the PMIC, right? It was some, not the PMIC, but kind of on this side of it. So that's what our face told us. Let's see if we can hone that in a little bit. And let's prompt to boot. Ready? Here we go. Plugging in to our DC power supply. All right, so now we're gonna let go and see if this prompts to boot. Hello, look at that. Ding. All right, when I see that, I immediately stop. All right, look around. Frozen tundra. This is all still frozen. When I see a lot of frozen and one spot, ding. I mean, that is crystal clear. Let's do it again, just in case you missed it. So keep your eyes on these 2 caps here and see if you think that you would notice them as kind of jumping up and raising their hand. And then we'll look them up and see what the heck is that. Is that gonna be some important line? And we'll figure out, are they actually short or not? Because we don't know for sure. This is just heat. All right, that looks nice and crispy. Frozen tundra. Okay, so here we go. Prompt to boot. Ready? Oops, let's turn DC power supply back on. Prompt to boot. Prompt, prompt, prompt. And I'm gonna let go. And I see my phone starting, it's in that sort of 0.2, 0.3. Look at that! Look at that guy. He's like saying, me, look at me, look at me. You! All right, that guy is, I mean, look at that. That guy is like super raising. It couldn't be more crystal clear. All right, so let's vote. Which of these tools do you think is better at detecting shorts in iPhones? Yay, free spray for the win again. I think I'm gonna just keep doing that so that I can cut down on my, you really should use the thermal cam comments on the channel. Okay, next, let's find out if that line, what line is that? I don't have no idea. Let's look it up. All right, so let's get our multimeter out And let's just kind of ask, are you short? And then we'll do some research. It's always good to know your line, because just because a dude gets hot doesn't mean that he's the cause of the short. We don't even know for sure that we have a short on this line. So let's find out. Let's go back to good old continuity mode and see. Now I'm pretty sure that we already tested this cap. In fact, I'm positive because I tested him on purpose, and so I already did this test. All right, so let's see. Let's park a probe on ground, and let's go to our cap here. Ground and quiet. That doesn't sound like a short. Ground on one side, quiet on the other side. So using continuity mode by itself, it's not a great tool. It's okay. Sometimes you'll find some stuff, and you'll find it really quickly. Fantastic. It's just a tool, just like freeze spray. It's just a tool. You got to combine everything together and have a big old strategy toolbox. Let's go to diode mode. Let's go to diode mode and find out what is the actual resistance to ground in diode mode on this test. All right, so let's stick red probe on ground, and one side of this cap is going to be ground, and the other side is 0.163. Now maybe that's normal. We don't know. In order to have a diode mode reading make sense, we have to have a good board to compare it to. And that's if it weren't for that, we'd use diode mode exclusively. So that's the drag of it, is that we have to have a known good in order to compare it to. Luckily, we do. It's not really known good, it's known beat up, but it's good on this particular line. All right, so over here, we've got those same guys. So let's just see on this donor board that doesn't have anything up in this area. Let's see what the diode mode reading is on this line. All right, so one side of our cap is ground, of course, and the other side is at 0.163. Answer, 0.456. So good board, 0.456. Bad board, 0.1 something. 0.4, 0.4, 0.1. That's a short circuit. Yes, so we found a problem. We do have a short, and now we know what line it is. So now we're hot on the trail. Hot on the trail. So next, let's see if we can go on a hunt and research what is that line. So let's go over, for sake of simplicity, to ZXW tool, and let's look that up. So this is iPhone 6 Plus. Let's get over to the iPhone 6 Plus. All right, is there any way to get freeze spray in Europe? Well, you could always just use a can of compressed air upside down. A lot of people do that. I mean, I think it's not some specialized thing. I would guess that, you know, anybody like kind of working with pipes, like a plumbing supply or something like that, this isn't a super specialized thing. I would think mechanics would have it. It's really not specifically for troubleshooting electronics. It's for all sorts of stuff. All right, so let's see, where is our dude? All right, so our dude, it was one or the other of these, I don't even remember. I think it was that guy. Okay, look at that. Now we can see the name of the line, and the name of the line, you can always look down here at the bottom, is PP6V0 LCM boost. That makes a lot of sense. 6V0 LCM boost. Now we don't have to know what that line exactly does, but we could take a guess. LCM sounds like screen or display. Boost, that sounds like something would be required for image or backlight, which we're missing probably for image. And that also is really consistent with something that would kind of, you know, the phone could largely be okay, but then when it tried to use that line, it would make the whole thing kind of have a problem. This is really, really consistent with, you know, what's up with this whole phone, that whenever LCM boost is you know, kind of turned on, which according to our graph is going to be in this sort of pattern like this, that every time that happens, likely our main voltage is getting dumped into that short, and that's pulling down our main voltage and kind of causing a little bit of a boot loop. Very, very consistent with our problem. Now, one thing I don't want to do is rely on ZXW exclusively. It's just a tool. It's a tool, just like our freeze spray is just a tool, just like our continuity mode is just a tool, just like our diode mode is just a tool. We got a lot of tools And I don't want to rely too much on ZXW, so let's go to the schematic itself. So let me see if I can find, I got to open up a 6+ schematic, because we really want to get to know our line. We want to know, what do you do? Well, what are the other choices that are on here? All right, let's see. 6+. I see 6. I see 6S. I see 6+. All right, let's see if this is going to work over here. Get rid of ZXW. And is that going to show the schematic? Yay! All right. Okay, so alcohol can be used to find a hot cap. Not really for phones, if you're really lucky, but it has to be a really hot short for phones. Most of the shorts that we see in phones are consuming, the battery voltage is very, very low. The number, like this short is 1 amp, and the voltage is also really low compared to a MacBook. So MacBooks burn up stuff. They get really hot and they'll boil alcohol. Phones sometimes can if the short is super hot, super strong, but it's not really it's nowhere near as crisp and obvious as freeze spray, which took us right to the exact spot. And we wasted so much time trying to find it using other methods. I mean, even your face could have found that before the thermal camera. All right, so let's go over here and we are gonna look up, let's look up our dude. So I think it was C1529, so let's look that up. C1529 and see what can we learn about this. All right, C1529 and his brother, C1502, are some caps that are on this line, PP6V0 LCM boost, and that line, my page, where'd you go? All right, and that line is an output here, an output of Chestnut. Chestnut is the image and touch power driver. So this is a little boost chip that takes VCC main, switches at a coil, there's the coil, Chestnut's coil, and is regulated through some magic here. It needs to know, hey, I've got a screen here. This is the line that's commonly torn in iPhone 6 long screw damage. It's the power enable line for Chestnut that tells Chestnut, hey bro, you got a screen attached, time to get busy. And then we've got some regulation. These are the whole house intercom lines from the CPU itself. And then we have a reset line, a line that goes to the PMIC. And then we have Chestnut's nut. So this is just a little scrotum with a cap that really has integral function to Chestnut, which some electrical engineer who can look at this stuff and be like, oh yeah, I know what that is, says, hey, that's a charge pump. All right, so given that, now we can start putting little tips and clues that we kind of gather together. C pump probably stands for charge pump. LCM boost, all right? And this is just a little path out from Chestnut that goes to these two caps. So my guess is what happens if one of these caps becomes a wire, it's going to drain this 6-volt LCM boost line away, and that 6 volts boost is required in order for Chestnut to be able to do his jobs and actually put out these other things. Now here's why this is cool, is because, a lot of times we want to like think in these really kind of like black and white ways, like no image, change Chestnut. This, it may be, but I'm going to go with, I think that this Chestnut is probably fine. So if you did change Chestnut, that's not going to solve anything because the problem isn't Chestnut. However, Chestnut is still not doing his job. So whenever you question a chip, rather than just be like, change chip, chip involved with function, change chip, like instead of being just so caveman, black and white, chip bad, must replace, think about, is this chip being told to turn on? Does this chip himself have a power source? What about his outputs? Are his outputs open line and therefore just not arriving at the destination? Are the outputs short to ground? Or in this case, is an output partial short to ground? And how would you test? Diode mode. Compare those outputs to a known good port. And especially the reason I'm doing that here is because if we look back and we said, hey, what if we just said, oh, it's got to be chestnut, I've got an image problem, and we don't see anything else wrong, it's got to be chestnut. What would it look like if we actually had to replace chestnut on this board? So let's think about that. Let's get rid of this and let's look at the board. Where is chestnut? Where are you at, bro? Chestnut. There he is. Now look at chestnut in this particular 6 Plus. Here is chestnut. It's really close to the CPU. It's got underfill squeezed up around the coil. Oh, there's our buddy Mesa chip for the home button. And it's all snugged in there with a whole bunch of underfill. How are we going to be able to change chestnut with all that underfill without bothering Mesa, bothering the CPU, floating the coil, bothering the strobe driver? That's going to be really, really hard to do. We might be able to do it if we had to, but it's a challenge. It's certainly not something that you want to be like, no image must change chestnut, bro. 100% tested working. You gotta kind of think first. So, shoo, looks like if we're lucky, and our problem is actually that we have a bad cap on the chestnut output line, then we're going to be able to clear this short without going anywhere near chestnut. Just leave him alone, and hopefully he'll be okay. All right, so let's see. Let's see what you guys are chatting about. I'm going to buy a case. Faulty charging IC, battery drain faster once you charge the phone. Is not relevant to an image or touch problem here. Okay, talking about other phones. Alrighty, let's do something first. So now it's time to say, okay, we know what line is short. It's the 6V0LCM boost line, and we know there's really nothing on it except for these 2 caps. And we know that freeze spray is saying that's your hotspot. Let's see if we can actually see a problem. So sometimes caps will show a discoloration or something kind of up with them, like a small crack. Let's just look and see if we can see anything that would kind of give us a clue as we kind of stare at these guys on the side. Sometimes you can't. So let's give it the old college try. And that's really tough on that side. I don't know if we'll be able to get our eyes in on the other side. Now these relatively large caps tend to fail more than the smaller caps, and I like to think of them as light bulbs. If you've ever kind of just dropped a light bulb on the floor, Sunday to today, just trying to change light bulbs around here, and she just, one fell out of her hand. Have you ever done that, where you drop a light bulb and you just know, well, there goes that light bulb? Because a light bulb, even if it doesn't break, it doesn't really like to survive a drop. And so that can sometimes be what goes on with these big caps. All right, so I think the last time I saw this same short, it was, I don't know, 6 months ago. And we could see a tiny crack on the cap. But on this one, I don't really think anything would jump out at me. As I compare these two, oh, you guys can't see that at all. As I compare these two, there may be a little hint of a vertical line. Let's see what you guys think. Where did he go? Right, kind of where the tweezers, like straight down from there. What do you think? Is there a vertical line there? A slight darkening, like a little hairline crack right there? It's a little unclear. All right, but I've already forgotten which of the 2 caps it is. So let's just go with, we'll take that one off first. And now I already forgot which one had that weird potential discoloration. Yeah, this guy. Right here. What do you guys think? Does he have a little hairline crack? Maybe. All right, so let's take him off. All right, and we'll see if that brings back our normal diode mode reading. So I'm going to use hot air for this rather than my conventional flick off method, because this is not for data recovery. This is for the sake of the phone. And because with only 2 caps on that line, I would like to put, I'm going to put one back, because this is not a VCC main where there's like 38 different caps. So, you know, screw any one cap. This is a charge pump line, whatever that is, and there's only 2 caps on it. They both seem to be pretty substantial, so I would like to replace it rather than just toss it. Alright, if this was for data recovery, I might attempt to toss it, but if this is the only thing wrong with this phone, then it would be silly to leave a phone in a state where it might have a problem over really just one bad cap. So I'm going to look around. I don't see any underfill around here, so there's nothing, no reason why I can't just grab this sucker off. Now this cap, if it is the cause of our short, remember this is not full short, this is partial short. This is dropping our diode mode resistance from 0.4 or 5 down to 0.1. So it's not a full short anyway. Alright, so there's our 1 cap. So now, how do we know whether or not we have made any difference? Have we changed anything or not? So here is our dude. Alright, we're going to let that board cool for a second. And let's just look at this guy, see if we see anything. Now that we can see all of his glorious sides. Hard to tell. Now we could ask him, you know, hey bro, what's your sign? What's your microfarads? And see if they match. But really, this is just going to be a diagnosis to say, did we solve the problem or not? If not, then it's likely to be the other cap. And if not the other cap, then it could still be chestnut, because there's still no rule that just because what gets hot is the cause of the short. It's just more likely to be the cause of the short. Doesn't mean that it is. Alrighty, let's speed up. Diode mode, let's see. Did we make a goddamn bit of difference? Alright, so this was our ground side here. And survey says 0.484. So there we go. 0.1 has now raised itself from the dead and become 0.484. So I'm going to guess that right now, even with that cap off, that we're likely going to have image back, and then we'll see whether or not this phone can now boot. All right, so like I said, I'm going to replace that sucker. So let's grab our donor board copy of that cap. All right, let's see. What should I do if I get tired of fixing phones all day, every day? You should meditate. That's what I'm going to go with. Christine, what should you do if you get tired of fixing phones all day, every day? You're like full of good ideas, I think. Do you have any good ideas? Huh? Listen to a good podcast. Yeah, watch YouTube all day. Here's what you should do. If you actually get tired of fixing phones all day, you should write a book about all the cool stories and funny customers and amazing data recoveries and all the adventures and times that you really saved the day, times where it was some kind of devastating disappointment, all the, like, you know, weird and crazy customers. Write a book about that. All right, let's try to move this a little bit so that you can see. Alright, let's see if I can get my tweezers out of there. Come on, bro. Stay down. Too much stuff in my hands. All right, let's see if we can get him to lay down, Sally. So we'll get some flux. And we'll try to get him to lay down without flying away. Don't fly away, bro. There you go, buddy. God damn it, I tried making that light be perfectly in view. Alrighty, now we are going to see if that made any difference. Alright, Jessa, can you connect MBTI power supply? Let's guess. Motherboard Texas Instrument power supply? What are we talking about? Connect now, PSU, please. Yes, boss. Just give me a minute. Just gonna let it not be blazing hot. Alright, not get tired if it's a hobby. Alright. Book time. Yeah, write a book. Exactly. That then goes to PMU. Jonathan. Remember what we talked about. You gotta look it up on the schematic. You gotta know your line. It's your baby. You gotta know everything there is to know about it. This is PP-LCM boost line. So go on a hunt. Go grab that 6+ schematic and you figure out, does this line go to the PMU? Figure it out. Maybe it does. Maybe it doesn't. But it's definitely important to know. All right. Should we wake up the hand camera? I think we should. And see what happens now. All right. First, always check any amp draw from DCPS. If there's no amp draw, then most likely it would be TriStar. No. Most likely, you should use your brain. It's just tools. There is no please, bro, it is this. It's different. Each one is a patient. And you have to listen to all of the symptoms. You have to ask them, you know, were you recently traveling outside of the United States on a safari? That will have a completely different diagnosis for the same set of symptoms as, you know, no, I got this way after hanging out at the preschool where a bunch of kids were coughing. You know, it's completely different. It's not every sick phone changed TriStar. TriStar is an oil change, but, you know, you have to have very, very thoughtful reasons. Ask lots of questions. Get lots of history. Always use your best tool, which is your eyes, for physical exam, to try to find those tiny little details that are going to guide you. Think about, how did the phone come to be like this? This one would have likely been a drop, just a drop. But there's no water damage and no physical damage. All right, waking up hand cam. Is hand cam awake? Here we go. Waking up because I want for you guys to see DC power supply. So remember what it was doing before. If you just got here, this had a very unusual DC power supply signature where it started out normal, 0.2 amps, 0.3, 0.4, 0.5 amps, and then it would go as normal to 1, 1.1, and then it would drop back down to 0.3, and then it would go back to 0.1, drop to 0.3. We actually looked at it on the new graphing DC power supply, and we could see that it really made this heartbeat. 1 amp. 300 milliamps, 1 amp, 300 milliamps, and that was a really unusual sign, and it did not connect to iTunes. All right, so here we go now. Let's see if anything is the same or different. Now keep in mind, when you do solve a hardware defect, that doesn't mean necessarily that you don't also have a software defect that was kind of hand in hand with your hardware defect. So kind of keep that in mind. All right, let's prompt to boot. And now let's see on DC power supply if it still does the same thing. I don't think it's going to, because I see an Apple logo, which we didn't have before. All right, now let's see if this thing can actually boot. Watch that DC power supply. That's normal. It looks really similar to how it did before, but we seem to be missing that sort of spike up to 1 amp and then drop back down. That's the normal, going up to that 1 amp. There is 1 amp. What we don't want to see is it dropping back down to 300 milliamps, that 0.3, and then kind of flip-flopping 1 amp, 0.3, 1 amp, 0.3, 1 amp, 0.3. All right, so now this seems to be different. This is kind of staying above 1 amp, and then it's kind of coming back down to the sort of normal range. That to me looks fairly normal. Let's see if it can actually boot all the way to the lock screen, and let's go ahead and plug it in and see if iTunes can detect it. So hopefully I won't drop the battery connector out while I plug it in. And now we're going to ask the question, can iTunes detect this phone? I hear that iTunes sound, and I see a sweet little girl. All right. I didn't plug in the home button. And look at that. Lo and behold, no touch. Surprise, surprise, surprise. Oh, wait, we do have touch. Probably janky touch, because it's a 6 Plus. And all 6 Pluses need to have Touch IC jobs. That's just the way they are. All right, so there we go. We have some kind of sporadic touch, which is going to be, might just be this screen actually. Is this the screen that goes with this one? Yes. All right, so we'll have to rule that out. You know, probably do a courtesy Touch IC repair on this one to get this one to go back working. But there you go. So what I like about this repair is the idea that number one, not every problem is as short. This one was. How did we know? Because it has to tell us where it hurts. Because it told us heat. I'm getting hot. And then we had to, that was our clue to figure out we've got an abnormal DC power supply signature and we feel heat. That's a short. Then we said, how do we find the short? And we tried a couple different ways. We tried, the old piece of crap thermal cam, which I am happy to now relieve of his duties and stick him back in the drawer to waste our time again next time. Thermal cam was really not even able to show us anything more than just what you can find with your fingers or your face, which is just getting hot. I think it's probably on the back side of the board, but not really sure. It's kind of getting hot. Not on the bottom. And that's pretty much what it could tell us. Then we moved to the yay method, freeze spray, and freeze spray immediately within seconds showed us, hey, you got a short on PP LCM 6V0 line. So that then we also tried to play around with just, hey, can we kind of randomly find it with a multimeter? Another great strategy for your strategy toolbox, and we found out that the answer was no. And we also saw a way that you can get trolled by that. If you get accidentally find a low resistance line like PP's CPU or GPU, a GPU power line. But we found our short. It was not full short, and we could only find it by using another strategy toolbox, Diode Mode. Diode Mode compared to a known good board, and we found a partial short on that 6 volt boost line out of Chestnut. We talked about how you can't just blame Chestnut. Chestnut was fine. We had no image. Chestnut was fine. Why? Partial short on one of his outputs. All right, so that one I thought was a good one. It was unusual. And I really think that one had a lot of good lessons to teach you guys. And let's see, Touch ID really cannot be repaired. Alrighty, and talking to Jonathan about TriStar. Okay, all right. See, well, if you guys choose to talk about phones that are not the phone that we're working on, then I have absolutely no idea what you're talking about. All right, that is it for this stream, and I will see you guys next time.